Combustion engines produce ultrafine nanoparticles that enter the bloodstream via the lungs, are carcinogenic and can cause heart attacks and strokes, Parkinson's and Alzheimer's disease. They are considered the most dangerous component of traffic-related air pollution in city centres. Diesel engines, which used to be characterized by black smoke, are now almost all equipped with particle filters. Their exhaust gas is cleaner than the ambient air. The filters are used in several 100 million vehicles and have proven their worth for health and climate protection, but they're not suitable for petrol engines. Let's take a look at the technology of particle filters in practice. Here in the beautiful town of Liechtensteige in Switzerland, we are visiting G Technology, experts for exhaust gas cleaning. Patrick Grütter shows how to carry out the work.
The problem with diesel engines has been solved for 20 years. First, the exhaust gases pass through an oxidation catalytic converter dock that eliminates hydrocarbons and CO and conditions the gases to oxidize the diesel soot. This is an axially open cell structure. The small solid soot particles can pass through and enter the following particle filter. Within this multi-cell filter, the entry channels are closed at the end, so the exhaust gas must internally pass through the porous ceramic walls, where the solid soot and ash particles are retained and the gases can leave through the exit channel. With this wall flow filtration, the exhaust gas is perfectly cleaned of solids and soot and is periodically burned to CO2. For the nitrogen oxide conversion, we additionally have an SCR catalytic converter, where the nitrogen oxides are reduced to pure nitrogen with the well-known AdBlue process. With this quite complex exhaust control technology, we have solved the problem for diesel engines. The diesel exhaust gases are cleaner than the ambient air.
Worldwide, however, there are many more petrol vehicles without filters. They have no visible smoke because their particles are smaller than those of diesel, which makes them even more dangerous, and the particle number can just be as high as with diesel. Air pollution in megacities today is dominated by nanoparticles emitted from petrol engines. In the last 2 years, particle filters have finally been developed for petrol engines, which, thanks to their innovative pore structure, eliminate more than 99% of even smaller particles right from the start. Retrofitting petrol vehicles with such particle filters is even easier than with diesel engines, because the exhaust gas temperatures are higher and much oxygen is available for burning the soot during load changes to periodically regenerate the filter. Within the Horizon framework, the European Union has commissioned the Swiss VERT Association to prove that retrofitting can be carried out in any vehicle workshop and that safe operation is guaranteed. The AeroSoft project operates a fleet of 50 vehicles that are typically used in city centres in Germany, Switzerland and Israel. The future individual costs will be less than 10% of the commercial value of the vehicle to be retrofitted. This video is intended to show how the retrofitting of the particle filters for this test fleet is carried out.
Indeed, worldwide, there are many more petrol than diesel engines. Since the 1980s, these have been equipped with the so-called three-way catalytic converter, which perfectly eliminates gaseous pollutants, but is permeable to nanoparticles. Since conventional diesel particle filters are not suitable for cleaning petrol exhaust gases, a new technology had to be developed, with very fine porosity, to clean petrol exhaust gases almost 100% from solid air contaminants. This comes now into the market for series automotive applications. But what about retrofitting the many old petrol vehicles? And that's what this project is all about, that we can also retrofit existing vehicles with particle filters. For installation in the vehicle, we have this customized kit with the appropriate clamp, where the sensitive, brittle ceramic particle filter is covered by a fiber mat and pressed into a chrome steel housing, which protects it against vibrations and the environment against radiated heat. From the engine, the exhaust gases come through the three-way catalytic converter and then flow through the particle filter towards the silencer. And here, for our testing application, we also have various sensors. Firstly, the exhaust gas temperature, here the surface temperature of the particulate filter, and finally here the differential pressure connections. In this Peugeot 3008, which we've just picked up from the customer for retrofitting the particle filter system, we're performing acceptance tests according to Swiss regulations.
The noise emission is measured, electronic onboard diagnostics are read out, and an exhaust gas test is carried out to record the gaseous pollutants and the concentration of nanoparticles.
If the checks are successful, the particle filter can be installed. To monitor the behavior of the filter system during the 6 months of test operation, we have an ECU to record the data, an ECU here to transmit the data,
which are then available in a cloud so that we can monitor the system's operating behavior at any time. We can now start the remodeling. First, the existing system is opened at the separation points. Only a few screws need to be loosened to remove the existing exhaust system, a job similar to replacing a silencer. The customized replacement system with a filter is then installed in the same place using the plug-in connections and attached to the underbody in the same way as the original system. This may require 30 to 60 minutes and completes the actual retrofit. We start the engine, take a short test drive to warm up, and then repeat the measurement at 2000 RPM without load. We can see that the newly installed filter has reduced particle emissions from 37,000 particles per cubic centimeter to 500, i.e. a separation efficiency of 98.8%, which will improve even further after a few hours of operation. The exhaust gas quality is therefore well below the particle concentration of the ambient air that we can measure with the same device, which is 10 times higher. The noise level has not changed significantly either. This data recording agrees with the regulations for retrofits of the Swiss Federal Roads Office, FEDRO, which will issue the necessary special permit for this vehicle to be operated in daily routine for 6 months. The converted vehicle is now returned to the vehicle owner, who will not notice any change in either the driving behavior or the noise. But his exhaust pipe now remains sparkling clean, so he can always check the effectiveness of the filter. There will be a similar mid-term test, and after the 6-month trial period, the system will be very carefully scrutinized. This technology should be widely available from 2026, primarily for low-emission zones in European city centers and then worldwide. We expect retrofit quantities in the millions, and thus a significant reduction in human mortality due to air pollution, and at the same time a significant delay in global warming by eliminating the radiation-absorbing black carbon aerosols. This emission reduction method can also be used for future engines that run on low-carbon fuels or even on hydrogen, for which soot particle emissions from the lubricating oil must also be expected.